Hello and welcome to Saurav's classes. Today we are discussing the subjective questions of the ISI Bstat paper, and this is question number 4, where we are told that g is a function which is differentiable and the derivative is continuous in the domain 0 to infinity, and g of x is equal to x in the same domain. And it is also told that g is not the identity function. That means it is not that g of g inverse of g of x is not equal to x, but g of x is equal to x. So which means that it is not an identity function, and we have to prove that g must be strictly decreasing in the positive domain of x. Now let us assume g of x to be equal to y. Then g dashed x becomes equal to y dashed. So now if I differentiate the function g of x equal to x with respect to x, then I get g dashed of g of x into g dashed of x equals 1. And I know g of x is equal to y, so I can write this as g dashed y times g dashed x equals 1. This implies if g dashed x is greater than 0, then g dashed y will also be greater than 0, and if g dashed x is less than 0, then g dashed y will also be less than 0. So which means that the signs of g dashed x and g dashed y will be the same. So therefore the if g double dashed x is greater than 0, then g double dashed y should also be greater than 0, and if g double dashed x is less than 0, then g double dashed y will also be less than 0. So now we differentiate this again with respect to x. So we get g double dashed y into y dashed times g dashed x plus g dashed y times g double dashed x equals 0. Or we can write g dashed y into y dashed is g dashed x, so g dashed x whole square equals minus g dashed y times g double dashed x. And we know from the first equation that we got, we know that g dashed y is the reciprocal of g dashed x. So we can make that substitution here, and we can write this as g dashed y times g dashed x whole square equals minus g double dashed x over g dashed x. That means g double dashed x whole cube, so I multiply both sides by g double dashed x and divide by g dashed y, so I get g dashed x whole cube will be equal to negative of this would be g double dashed y, so negative of g double dashed x upon g double dashed y upon g double dashed y. So now we know that if the sign of g double dash x is positive, then the sign of g double dash y will also be positive and vice versa. That means the quotient of g double dash x by g double dash y will be always positive. If both are negative, even then it is positive, and if both are positive, then also this is positive. That means g dash x whole cube is negative. That means this is less than 0. So which means g dash x is less than 0, because it is given that g dash x is continuous. So therefore g dash x has to be less than 0. Therefore gx is strictly decreasing in x greater than 0. Next we come to question number 5, where we are given a polynomial px which is defined as x20 plus the sum of ai xi from 0 to 19, and it is also given that px equals to p of minus x and p of k is equal to k square for k equal to 0, 1, 2, etc. So that means if I combine all of this, I will get, if I combine these two, I can write that px equals x square for x being any integer, and for any natural number, and since px is equal to p of minus x, so therefore this also holds for x being any integer. So that means this is a quadratic for integer values of x. So therefore the behavior of px will be quadratic for all integral values of x, and for non-integer values of x, px will follow this function. So that means px will be equal to x to the power 20 plus a19 x to the power 19 plus a18 x to the power 18, and so on up to a2 x square plus a1 x plus a0. Now when I am approaching 0 from both sides, since it is symmetric on both sides, so I can take any one side. So when I am approaching from this side, then the as x approaches 0, then the terms of higher order x20, x19, x18, etc. becomes insignificant. So that means px can be approximated with the last three terms as x tends to 0. So the significant terms will be a2 x square plus a1 x plus a0. Similarly, as x tends to 0, sine square x is approximately equal to x square. So therefore we can see that the function or the limit will be of the form limit of x tending to 0 a2 x square plus a1 x plus a0 upon x square. Now we apply L'Hospital's rule, because we can see that this is approaching the value of 0. So obviously a0 will be equal to 0 here as x approaches 0. So this would be 0. So that means if I apply L'Hospital's rule, I will get limit x tending to 0 to a2x plus a1 over 2x. And if I again apply L'Hospital's, this becomes limit x tending to 0 to a2 by 2, which is a2. So the limit of this function will be equal to a2.